Now see subquestion 7 from exercise 1.3. Now here in base trigonometric function sin x is given, in power algebraic function x is given. That means here given problem in the form f of x raised to the power g of x. So we don't have formula for direct differentiating this function. So we take log here. So write in solution, let y is equal to sin x raised to the power x. So write here, taking log on both sides. So take log here, we write here log y is equal to log of sin x raised to the power x. So we apply here first property, log m raised to the power n is equal to n log m. So we write this power in multiplication. So we get here x into log of sin x. Now we have to differentiate this function with respect to x. So write differentiate with respect to x. Now in RHS we have to apply product rule, and in LHS we have to apply chain rule, that is rule for composite function. So write a derivative of log y as 1 by y into dy by dx is equal to, here we apply product rule. So first function is x, second function is log of sin x. So write first function into derivative of second function plus second function into derivative of first function. If you have the practice for differentiating the function for composite function, so you write its derivative directly while applying the product rule. So write here first function as it is, derivative of log is 1 upon, so we write here 1 upon sin x. Then we have to find the derivative of this sin x. So write here derivative of sin x as cos x plus log of sin x as it is into derivative of x with respect to x is 1. So write in next step this cos x upon sin x, which is cot x. So write here x into cot x plus log of sin x into 1 is log of sin x. Now we have to find value of dy by dx. We have here value 1 by y into dy by dx. That means we have to transfer this y to right hand side. So we write here, therefore dy by dx is equal to y into x cot x plus log of sin x. So in next step, substitute the value of y, that is sin x raised to the power x. So we write here final answer as, therefore dy by dx is equal to value of y is sin x raised to the power x in bracket x cot x plus log of sin x is the final derivative of given function. So in this way, first we apply log, or we take log on both sides. When this value in the form of log m raised to the power n, then we have to apply the property log m raised to the power n as n log m. So we apply that property, then we differentiate the function and apply the product rule in RHS. Now see subquestion 8. We have to differentiate this sin x raised to the power x. Here this power is for this sin x, and here this x is for this variable x only. That means these two are different. So first we write here, let y is equal to sin of x raised to the power x. So here we don't directly take log, because this raised to the power x is not for this sin x. This x is only for this variable x. So we have to differentiate this first, then when terms arrive x raised to the power x, that means in base also variable and power in variable. So in that case we have to apply the log. First we apply the rule for composite function, that is, so first we write here differentiate with respect to x. So derivative of y is dy by dx. Derivative of outer function, that is derivative of sin x, is cos. So we write cos of x raised to the power x into d by dx of x raised to the power x. That means if we consider this x raised to the power x as u, so we write here when x raised to the power x is equal to u. That means differentiating this function, differentiate with respect to x. In that case we get d by dx of x raised to the power x is equal to du by dx. So for calculating this du by dx, we have to take log of this x raised to the power x. So we find derivative by taking log. So write this as equation number 1. So we write here taking log on both sides. Therefore log u is equal to log of x raised to the power x. So we write this x raised to the power x as x into log x. So differentiate this, differentiate with respect to x. Therefore derivative of u is 1 by u into du by dx. Here we have to apply product rule for RHS. So first function into derivative of second function plus second function into derivative of first function. So x into derivative of log x is 1 by x plus log x into derivative of x with respect to x is 1. So cancel this x with x. We write 1 plus log x. Now we require du by dx. Here we got 1 by u into du by dx. So we write here du by dx is equal to u into 1 plus log x. Now substitute the value of u. Now value of u is x raised to the power x. So write x raised to the power x into 1 plus log x. So we substitute this du by dx, that is d by dx of x raised to the power x in equation number 1. So right here put in equation number 1. So we write here from equation 1. So in equation 1 we substitute the value of derivative of x raised to the power x. Therefore dy by dx is equal to cos of x raised to the power x into derivative of x raised to the power x. We get x raised to the power x into 1 plus log x. So in this way you have to differentiate this sin of x raised to the power x. So don't confuse with sin x raised to the power x and sin of x raised to the power x. These are not same. Now see main question second. Differentiate with respect to x. Sub question first. X raised to the power e plus x raised to the power x plus e raised to the power x plus e raised to the power a. So here for this second term we have to apply log properties for differentiating this second term. So first we write a given function as, in solution write let y is equal to x raised to the power e plus x raised to the power x plus e raised to the power x plus e raised to the power e. For second term we have to apply log. So we write this second term as u. So write here x raised to the power e plus u plus e raised to the power x plus e raised to the power e, where u is equal to x raised to the power x. Now we have to differentiate this y with respect to x. So write here differentiate with respect to x. So write here derivative of y as dy by dx. Now these four terms are in addition. So we have to apply derivative of first plus derivative of second plus derivative of third plus derivative of fourth, that is addition rule. So write a derivative of first. So d by dx of x raised to the power e plus d by dx of u plus d by dx of e raised to the power x plus d by dx of e raised to the power e. Now x raised to the power a, that is of the form x raised to the power n. So we write here e into x raised to the power e minus 1 plus derivative of u we find separately, right here du by dx plus derivative of e raised to the power x with respect to x is e raised to the power x, and here e raised to the power e, that is constant, so its derivative we write 0. So we write this as e into x raised to the power e into x raised to the power minus 1 plus du by dx plus e raised to the power x, or you can keep x raised to the power e minus 1 as it is, or you can write in this way also, e into x raised to the power e upon x plus du by dx plus e raised to the power x. Now we find separately the derivative of this u equals to x raised to the power x. We have u is equal to x raised to the power x. So differentiate with respect to x. Therefore derivative of u with respect to x is du by dx. But here we cannot find derivative directly, or you can remember derivative of x raised to the power x directly. So for differentiating this we have to take log on both sides. So right here log u is equals to x into log x. How we write this, that we see in previous example, or you can add one more step for it. So right here log u is equals to log of x raised to the power x. So we write this power in multiplication. So for differentiating this log u, we have to write here derivative of u, that is 1 by u into du by dx is equal to, here we have to apply product rule, first function into derivative of second plus second function into derivative of first. So we write here 1 plus log x as a derivative of this x raised to the power x. Then we have to write this u in RHS. So we write here 1 by u into du by dx. Then we transfer this u to right hand side. So we get du by dx is equal to u into 1 plus log x. So replace the value of u as x raised to the power x. So x raised to the power x into log x. So if you remember the derivative of x raised to the power x as x raised to the power x into 1 plus log x, then you can write directly derivative of this x raised to the power x as x raised to the power x into 1 plus log x at this step. So we have to replace the value of du by dx. So we denote this as equation number 1. So right here, therefore from equation 1 dy by dx is equals to e into x raised to the power e upon x plus x raised to the power x 1 plus log x plus e raised to the power x. So in this way you have to differentiate this given function. Now see subquestion second, x raised to the power x raised to the power x plus e raised to the power x raised to the power x. So first we represent the given function as y. So write in solution, let y is equal to x raised to the power x raised to the power x plus e raised to the power x raised to the power x. So here first term we consider as u. So write y is equal to u and the second term as v. So we have to find the derivative of first term plus derivative of second term. So we find here derivative separately. Therefore differentiate with respect to x. Therefore derivative of y is dy by dx, derivative of first term plus derivative of second term. So we find separately derivative of u and derivative of v. So first we take u as x raised to the power x raised to the power x. So right here take u is equal to x raised to the power x raised to the power x. So we solve this taking log. So right here taking log on both sides. So right here log u is equal to log of x raised to the power x raised to the power x. So write this x raised to the power x in multiplication. So write x raised to the power x into log x. Now here this x raised to the power x is also of the form f of x raised to the power g of x. So we have to write this as w, or you can write derivative of x raised to the power x directly. So first we write here log u is equal to x raised to the power x into log x. So we have to differentiate this with respect to x. So right here differentiate with respect to x. So derivative of log u is 1 by u into du by dx is equals to, so write here product rule for RHS. So first function into derivative of second function. So right here d by dx of log x plus log x into d by dx of x raised to the power x. So x raised to the power x as it is, derivative of log x is 1 by x plus log x into, if you know the derivative of x raised to the power x directly, if you not know the derivative of x raised to the power x directly, then you have to substitute at the place of x raised to the power x as w, then differentiate that value and then substitute that value. But we know derivative of x raised to the power x that we calculated in previous example. So write derivative of x raised to the power x as x raised to the power x in bracket 1 plus log x directly here. So this is a derivative of 1 by, this is value of 1 by u into du by dx. We require the value of du by dx only. So transfer this u to right hand side. So right here du by dx is equals to u into, so write u in bracket x raised to the power x upon x plus log x into x raised to the power x into 1 plus log x. Now replace the value of u as x raised to the power x raised to the power x here. So we replace this u as x raised to the power x raised to the power x, or you can take this x raised to the power x common from both the terms. So we take x raised to the power x common. So write here 1 by x plus log x in bracket 1 plus log x. This is derivative of first term. Now we have to find derivative of second term here. That is a derivative of v. Now v is equals to, we write here take v is equals to e raised to the power x raised to the power 10. So we have to take log on both sides, taking log on both sides. So we take here log on both sides. So write here log v is equal to log of e raised to the power x raised to the power x, that is x raised to the power x into log e, and log e is 1. So we write x raised to the power x. So we get here log v is equal to x raised to the power x. So differentiate this function with respect to x. Therefore differentiate with respect to x. So derivative of log v is 1 by v into dv by dx. Derivative of x raised to the power x is x raised to the power x in bracket 1 plus log x. So dv by dx is equals to v into x raised to the power x into 1 plus log x. So we replace the value of v as e raised to the power x raised to the power x. So right here dv by dx is equals to e raised to the power x raised to the power x into x raised to the power x into 1 plus log x. We denote this as equation number 3rd. Derivative of u we denote by equation number 2nd. Derivative of v we denote by equation number 3. Now from equation 1, 2, 3, that means we substitute the value of du by dx, then we substitute the value of dv by dx, then we get the derivative of y with respect to x. So write from equation 1, 2, 3, dy by dx is equal to du by dx plus dv by dx. Du by dx we calculate x raised to the power x into x raised to the power x in bracket 1 by x plus log x in bracket 1 plus log x plus derivative of v we calculate e raised to the power x raised to the power x into x raised to the power x in bracket 1 plus log x. So in this way, first we have to find derivative of first term and then we have to find derivative of second term, then substitute the value of both the derivatives of first term and second term.